So let's discuss about a secret technique in solving an integration by parts, which is the DI method. What does DI method looks like? Think of it this way. It is a tabular method. Basically, it is a table, but it consists of two columns. We have your first column as your D and your second column as your I. All right. So in your first column, your D stands for the derivative or differentiation. Okay. So in this column, you're going to simply differentiate a function. And in this column, expect that there shall be an alternating of signs. Okay. In As you proceed to the next row, the signs are changed. So first row positive, second row negative, third row what equals one positive, and fourth row it's negative. Now for your I, on the other hand, I stands for integration or integral. So you're going to integrate a specific function. And unlike for the D column, there is no alternating signs in this column. Okay. So why not let's try to the examples. Okay. So due to this, let's first discuss about the cases. Okay. Then apply it to the example. So first case. Okay. We have an example. Let's get the integral of x squared times cosine x. So we will apply DI method. So DI. So remember that your D we have positive, negative, and so on and so forth. So in your D, don't forget to put the alternating signs of positive and negative sign. So pick which of the function you're going to differentiate and the other will be integrated. So for me, I'm going to put x squared to the D column. So I will differentiate x squared. And cosine, I'll put it in your I column, wherein you're going to integrate your cosine. So why did I pick x squared to the D column and cosine x to the I column? Because in your D column, right, you're going to differentiate. So if we differentiate x squared continuously, it will reach to 0. Let's try that. What is the derivative of x squared? We have 2x. What is the derivative of 2x? We will have 2. And what is the derivative of 2? 0. See, it reaches 0. Now let's get the integral of cosine x. The integral of cosine x is sine x. The integral of sine x is negative cosine x. And the integral of negative cosine x is negative sine. Okay? Now, as you can see, at the fourth row, there is a 0 on your D. So if there is a 0 on your D column, then at that point, you're going to stop right there. So that is your first case. Stop at 0. Again, stop at 0. So in the fourth row, there is a 0. There's a 0 in your D column. So you're going to stop at the fourth row. So what are you going to do? We can now find your answer by multiplying two functions diagonally. So x squared times sine x, we will have x squared sine x. Next, remember, you have negative sign here, so don't forget, okay? Negative 2x times negative cosine x, so we will have positive 2x cosine x. The next, positive 2 times negative sine x, we will have negative 2 times sine x. Plus, don't forget your c. And that is your answer. See, it's actually simple. All right. So this is for your first case. Now let's proceed to the second case. So for your second case, wait, let me write this one first. let's just say we have a problem, which is the integral of x cubed times ln of x. Okay. And let's get the derivative for derivative. Let's get the integral for this one. So as always, we will have di, and remember for your d, okay, there's positive, negative, positive, and negative, and so on and so forth. Now, obviously, I know what you're going to put. You're going to put your x cubed to your d, because if you're going to put your x cubed to your d column, it will reach to 0, right? So let's try that, x cubed. Then for your ln of x, that would be in your I column. So let's get the derivative of x cubed. You have 3x squared. The derivative of 3x squared, we will have 6x. The derivative of 6x, we have 6. And the derivative of 6 is 0. Okay, that's good. We reached 0. Now, how can we integrate your ln of x? So you're going to integrate your ln of x by applying integration by parts. Okay? And you can use DI method for your ln of x to be specific. However, after you're going to get the integral, right? You're going to put the integral for your, right? You're going to put the integral for ln of x here, right? What more if there would be more rows to fill up? So meaning, getting the integral of ln of x is more complicated than getting the integral of the x cube. Okay, because as you can see, take a look. The integral of ln of x, okay, what I call this one, it involves integration by parts. And then you will do the same thing for the third row, to the fourth row, and until you reach at the fifth row. So it's complicated, right? So why not let's switch the roles? Okay, instead of putting x cubed on the D column, why not let's put x cubed on the I column, wherein you're going to integrate your x cubed. So here, this would be ln of x. So let's get the integral of x cubed. So we will have 1/4 times x raised to 4, and then we will have what I call this one? We will have 120 times x raised to 5, and yada, yada, yada. See, we can easily integrate x cubed. It's easy, all right? Compared to ln of x, you're going to apply other techniques. While unlike here for x cubed, it's easy, all right? It's totally easy. Now, let's get the derivative of your ln of x. So we have 1 all over x. So if you're going to get the derivative of ln of x continuously, what will happen? Basically, yeah, it will differentiate, but it will not reach to 0. Because if you continuously differentiate ln of x, what exists is the number, the variable, and the sign itself, and the exponent. So meaning, there's no 0 as a result, okay, if you're going to differentiate it thoroughly. So what would you do in this case? Wherein there will be no 0 result if you would differentiate. Now, here's the thing. As you can see on the second row, right, we get the derivative of your ln of x. And then in here, we get the integral of your x cubed. Okay, so this is the first row where we differentiate the ln of x and integrate x cubed, right? So, can you integrate these two after you multiply them? Try to multiply these two and integrate them. So if I'm going to multiply it, ln of x times 1/4 x raised to 4 and integrate it. So obviously, x will be cancelled. This 4 will be reduced to 3. So I will have 1/4, the integral of 1/4 times x raised to 3 dx. So the answer is yes, you can integrate 1/4 x cubed. Therefore, if you believe that this row can be integrated, then you're going to stop right there. Okay? So for your case 2, stop when the uh, wait, let me fix my handwriting. Stop when the row can be integrated. Okay? Once again, stop when the row can be integrated. So since this row can be integrated, so we will stop right here. Okay? So how can we get the final answer? Okay? So in this case, first, obviously, we're going to multiply it diagonally. So since at this row, we can integrate them, so we will stop at this row. So multiply ln of x times 1/4 x raised to 4. We will have 1/4 x raised to 4 times ln of x. Then, these two, you're going to integrate them. Okay, so this is negative the integral of ln of x times 1/4 of x raised to 4. Okay, so let me move this DI method here. So if you're going to get the what do you call this one? Get the simplified. Okay. If you're going to get the simplified form for this one, if you're going to recall, this is 1/4 x cubed, right? So now let's get the integral for this one. So the integral for 1/4 x cubed is 1/4 times 1/4 times x raised to 4 plus c. So hence, you will have 1/4 times x raised to 4 times ln of x minus 1 all over 16 times x raised to 4. You can factor out this one, but again, factored or not, simplified or not, this is your final answer. See? So that's for your second case. Stop when the row can be integrated. Okay? Now, here is our last case. Okay? For your last case, this is your third case, or case number 3. Let's get the integral of e raised to x times cosine x. Okay? So as usual, we will put the I method. So pick which one would you differentiate and pick which one would you integrate. So in here, you can put your e in your d and cosine to your I. Or we can switch the roles. We can put cosine to your d or your e to your I, because the answer is still gonna be the same. Okay? So if ever you've encountered this case, so it's okay. Pick which one would you like to integrate and which one would you like to differentiate. So for me, I'm going to what do you call this one? I'm going to simply differentiate cosine x here, and I will integrate e raised to x. So I will have cosine x and e raised to x. Remember, again, it's up to you whether you like to put e raised to x in your d or cosine x to your I. It's up to you. There is no problem. Okay? So, now, let's get the derivative for cosine x. So we will have negative sine x. The derivative of negative sine x will be negative cosine x. And the derivative of negative cosine x is sine x. Okay? And so on and so forth. Now here, if you're going to get the integral of e raised to x, will just be e raised to x, e raised to x, e raised to x, and so on and so forth. And as you can see, both of these functions, if you're going to get the integral or the derivative of it, it will not reach to 0, which is it's so obvious because as you can see, for your derivative, we have cosine, then negative sine, then negative cosine, then sine, then cosine, so on and so forth, right? So meaning, it's still what? Doesn't change. The pattern is repeating. Okay? So it will not reach to 0. Now go to your I column, e raised to x, e raised to x, e raised to x, e raised to x, so on and so forth. It will still not reach 0. Okay, it will not. So what are we going to do? So despite the negative sign, okay, let's ignore the signs, okay? Let's ignore this one and the signs, okay? Let's ignore them for a moment, okay? Do you think there's a repeating row here? Okay, once again, remove disregard first the sign, okay? Disregard this one and disregard the signs in your derivative and in your integral column, okay? Remove the sign first, okay? Observe the functions, okay? Now, do you think there's a repeating row here? Right, first we have e raised to x and cosine x, which is this one, right? We have this one, okay? But take a look, take a look. We have another cosine and e raised to x here, right? So it's repeating, okay? Despite the sign, it's still there. So what are we going to do? We will stop right here. We will stop right here. So this is your third case. Stop at the repeating or repeat, I'm just going to say repeating. Repeating row. Wait, wait. Let me fix my handwriting. Repeating row. Okay. So take a look. Look at this one. They are the same, right? Despite the signs they have, they are the same indeed. So what we're going to do is we're going to stop at the third column. Okay. So we will stop right here. So what to do? Okay. So first, multiply them diagonally. So, wait, wait. Let me erase this one. There we go. So cosine x times e raised to x, we will have e raised to x times cosine x. The next, here we have negative and negative. So this is positive. Okay. So this is positive sine x. So positive sine x times e raised to x, we will have plus e raised to x times sine x. Then, for the last row, you're going to multiply and integrate this one. So we will have the integral of negative cosine x times e raised to x. Or in a proper format, you can rewrite it at this way. Okay? So that's it. So once again, what I did here is first, I multiplied this one diagonally. Cosine x times e raised to x. That's it. The next here, since we have negative here and we have negative sine x, so this would be positive sine x. So sine x times e raised to x, so this would be e raised to x times sine x. Then lastly, on your last row, which is your third row, by the way, multiply them together and integrate them. So negative cosine x times e raised to x is negative e raised to x times cosine x. Then integrate, which is this one. So I'm going to move it here. Okay. So what are we going to do? Okay. Now let's take a look. Right, we have this one, negative e x raised to cosine x. And as you can see, they have a similarity. You see, we have positive e raised to x times cosine x, and we have negative e raised to x times cosine x. So these two are similar terms. Okay, both of them are similar. So what are we going to do? Transpose this one to the left. Okay, so by doing so, we will have e raised to integral e raised to x times cosine x dx plus this one. This would be positive integral of e raised to x times cosine x dx is equal to e raised to x cosine x plus e raised to x sine x. So obviously, since both of them are similar, you can add them together, which result to having 2 times the integral of e raised to x times cosine x. So that's it. So we have this one. Okay. So what's next after that? So after that, we will divide both sides by 2. So I have no space. I'm just gonna write it. So after you're gonna divide it by 2, you will have e raised to cosine x plus e raised to x times sine x all over 2. And that is your final answer. That's it. That is your final answer. Okay. So let me rewrite it here. So we have the integral of e raised to x times cosine dx is equal to e raised to x cosine x plus e raised to x sine x all over 2 plus c. So that is your final answer. So you see, basically that's it. That's your third case. Okay. So first, stop at the repeating row. Okay. Then after that, basically, what I call this one? What's that? What's this? Combine it to the given here, add them together, then that's it. Okay. So basically, if you're going to take a look once again, okay. So how would you know if they are repeated? So first, disregard the signs. Okay. Just take a look at the functions. Okay. And plus, it's okay if there would be some constants here. For example, there's a constant, what do you call this one? For example, this is e raised to 2x. The integral of e raised to 2x is 1 half times e raised to 2x. Then the third integral, we have 1/4 times e raised to 2x. So it's okay if there would be a constant as long as the functions are repeated. Okay. So once again, okay, first disregard the signs, and then the constant, if there would be constant given here, just like this one, for example, disregard them. All you need to focus is the functions given. Okay. So let's basically try one more example. Okay. For this case. So how about if we have this one? Okay. The integral of e raised to 3x times sine x. Okay. So as usual, bi. So for me, I'm going to pick sine x in here. And for me, the integral here would be e raised to 3x. Positive, negative, positive, negative. The derivative of sine x is cosine x. The derivative of cosine x is negative sine x. Here, the integral of e raised to 3x is 1/3 times e raised to 3x. And the integral of 1/3 times e raised to 3x, we will have 1 all over 9 times e raised to 3x. Okay, now, stop right here. Disregard the signs. Okay? And disregard the constant. Disregard them for a moment. Take a look that was there a repeating row? Do you think there is a function that is the same as to the other row? So right, we have e raised to 3x sine x, which is basically on your first row, right? And as you can see, on the third row, we have sine x and we have e raised to 3x. So meaning they are the same as the given. So if they're the same as the given, you're going to stop right here. Despite the constants and the sign the function have, don't regard it. Okay, like don't mind it for a moment. Just mind the functions. So since we have e raised to 3x and sine x, and we have sine x and e raised to 3x on the third row, so we're going to stop at the third row. Okay, so let's do that. Multiply positive sine x and 1/3 e raised to 3x. So we will have e raised to 3x times sine x. Here, negative cosine x times 1 all over 9 times raised to 3x. So we will have 1 all over 9 times e raised to 3x times cosine x. Then lastly here, Wait, let me erase this one. Okay. Then lastly, okay, when it comes to this one, what to do? Multiply these two together and integrate them. So negative sine x times 1 all over 9 e raised to, wait, I forgot. Okay, right. 9 e raised to 3x. So we will have negative 1 all over 9 e raised to 3x. Then integrate them. So we will have 1 all over 9 e raised to 3x times sine x. Okay, see? That's it. All right. So that's how you do it. Okay. Multiply diagonally sine x to 1/3 e raised to 3x. Multiply negative cosine x to 1 all over 9 e raised to 3x. Then multiply these two, the third rows together, negative sine x and 1 all over 9 e raised to 3x. We have negative 9, 9 e raised to 3x times times, wait, negative 1 all over 9 times e raised to 3x, then times sine x. Then integrate them both. So we multiply them together and we will integrate them. So as you can see, okay, since we have e raised to 3x sine x and we have e raised to 3x sine x on the third term, we can combine them by putting this one on the left side. So we will have, I'm just gonna copy this one. So we will have copy, paste, there you go. Then this one as well, but this would be positive since I've transposed it to the left side. Okay, so we will put it here and add them together. Okay, then here as well. Okay. Oh, whoa, 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 hold on. That's it. We can simply bring up the constant here. So we will have the integral of e raised to 3x sine x dx plus 1 all over 9 times the integral of e raised to 3x times sine x. So if you're going to add them together, you know, you will have, wait, sorry. You will have 1 plus 1 all over 9. That's basically 10 all over 9. Yeah, that's 10 all over 9. Okay. Then times e raised to x times sine x. That's it. Okay. Then let's copy the rest of the terms here. There you go. Now, what we're going to do is to divide both sides by 10 all over 9. And then we can now get your final answer. So your final answer, e raised to sine x, e raised to x times sine x, forgive me. So for this one, 1/3 all over 10 all over 9. So we will have 10 all over 3 times e raised to 3x times sine x. And here we will have um, minus 10 times e raised to 3x times cosine x. And that will be now your final answer. Okay, that's it. So you see, that's basically how you apply DI method. And there are three cases. Okay, so yeah, basically that's it. Okay, that's basically it. All right. Wait, let me take a look if my fractions are correct. Because if I'm going to divide this one by 10 all over 9, I'm going to divide first this one, 10 all over 9. So I will have 1/3 times 9 all over 10. Oh, I'm wrong. Wait. I'm wrong. So I will have 3 over 10. Okay. 3 all over 10. Then for this one, I will have 1 all over 10. Forgive me. This one, 1 over 9. Yeah, 1 all over 10. There we go. So yeah, that is basically your answer here. Okay. So that's it. Okay. Forgive me if I had mistakes. So yeah, to sum it up, first case, stop when there is a specific row that reaches to zero. Number two, stop when you can actually integrate a row. And three, stop at the repeating row. Okay? So yeah, basically that's it.